Constant acceleration. Here's what's happening. Our objectives, we're still working on describing the position, velocity, and acceleration of an object using representations of that motion. And to get there, we need to know that for constant acceleration, there are 3 kinematic equations that can be used to describe instantaneous linear motion in one dimension. A couple of vocabulary terms. Kinematics just means the study of motion. And constant acceleration is acceleration that is not changing. Here are the kinematic equations. We can use these to predict motion or to see what has happened if we're going in reverse. So notice I have given each equation a name, average velocity equation. That one is what we've been working on. And the included quantities. We have t, we have the position, or in this case, the displacement. We have our final velocity. Instead of using v sub f, I use v sub x. And then the initial velocity in the x direction. As long as we're moving along the x-axis, that's what it'll be. Then we have the velocity as a function of time, which is our final velocity equals our initial velocity plus our acceleration times our time. The no time equation is our final velocity squared plus our initial velocity squared plus 2 times a times our displacement, delta x. Then the displacement equation is our final position equals our initial position plus our initial velocity times time plus 1/2 at squared. Again, notice the included quantities. So that's x. What about y? That's it. Everything is now y. So now whenever we're dealing with a vertical motion, we can just use the y equations. If we're dealing in vertical motion, you cannot use x equations. Motion in the x-axis has to be completely independent from motion in the y-axis. We're going to talk more about that soon in a different lesson. How do you know which equation to use? Well, you just guess. G stands for given. Write down your given information. U is unknown. What information is the question asking you for? E is the equation. What equation can you use? That will give you your unknown while using the given information. And then we solve it, and then we check to make sure it makes sense. There are some secret messages you need to be aware of. Some words are said, but the meaning may not be explicit, so watch out for these. Whenever you see the word rest, that could mean your final or initial velocity equals 0 meters per second. If you see stop, that means your final velocity is 0 meters per second. If you see the word uniform, that means the same. Whenever you drop something, then that means your initial velocity equals 0 meters per second. And whenever there's any kind of vertical motion, you have to know the acceleration in the y direction will be negative 10 meters per second squared, or g. Here's a worked example. A stone is thrown vertically upward into the air with an initial speed of 10 meters per second. After how many seconds does its velocity become 5 meters per second downward? Well, remember that we're going to be using the guess strategy. We're going to list out our given. We know the initial velocity is 10 meters per second given to us in the problem. We also know that g is negative 10 meters per second squared because it says vertical in the problem. And we know our final velocity is negative 5 meters per second because 5 meters per second downward. The unknown is going to be the time because it says after how many seconds. The equation that we could possibly use, well, let's bring up our equation chart here. And this is why this thing is so useful. So we already know that we need time. So what's the one thing we can eliminate? The no time equation. Next, we can figure out what variables are given to us. We know the initial velocity is given to us, so any equation that has initial velocity makes it a good candidate. And then we also know the acceleration. Maybe we need it, maybe we don't. We need it. And we know the final velocity. So that means this velocity as a function of time is a great candidate because there's 3 variables. If you know 3 out of the 4 variables, then you can use that equation. Any of the equations will work. It's physics, so the physics will stay the same. So we'll use velocity as a function of time. And when we do that, we're going to write the equation and then solve for what we're looking for. We're going to get time all by itself, dividing by acceleration, subtracting our initial velocity, and plugging in our numbers, and we get 1.5 seconds. And then, of course, does this make sense? 1.5 seconds, pretty fast time, but this is something going up and down. That seems reasonable to me. Next steps, make sure you're doing lots of practice problems with these, lots and lots of practice problems. For more practice, there's your AI prompt. Make sure you ask each other and ask me. Keep asking until you get it.